Hey everyone, Endgame here, finally back with another video. I know it's been a minute since the last OSCP video, but I've been taking some time to rest and plan ahead for my next content creation endeavors, and I also started a new job. As a result, I'm still kind of striking my new work-life balance a bit, but so far everything's going swell. I also spent the last few weeks building out a new lab using Proxmox, and I intend to start streaming a small series where we can all hack my lab together live. I was inspired by watching Mubik stream retired hack-the-box machines, and I thought that I should probably do something similar. I wanted to be a bit more unique, though I will also likely do some hack-the-box machines. I really wanted to keep doing that freeform hacking video style, kind of like when I was doing my OCP training. Just kind of pop boxes and let you all see my thought process, so I figured that maybe streaming might be a better format for that, and we'll see how it goes. That said, this video series isn't that. This series is me taking a stab at a more organized and scripted video approach. Welcome to the Offensive Security C2 series. I intend to make tons of videos centered around topics on offensive security, and I wasn't really sure where to start, so I just kind of picked a topic that was relevant to the research I presented on at the Red Team Village for DEF CON this year, and that was C2s. Don't know what C2s are? No problem, that's exactly what this video is for. Before we dive in, I mentioned in my last video that I'd be adding a little disclaimer to these videos. Remember that this does nothing more than clearly state the intent of my videos in a good faith attempt to prevent them from being misinterpreted by any terms of service on whatever platform this is viewed on. So I'm going to throw that disclaimer up here real quick and then we'll get into the video. Alright, so let's dive in. What the hell is a C2? CC, CO2, corn and carrots, crazy chipmunks. No, it's not any of those things. C2 is just fancy InfoSec terminology for command and control. And you may see it represented as CNC, C and C, or just C2. The idea of command and control is what you may think of when someone says the word botnet. I'm sure if you ask the average person to try to explain a botnet, they may choose to describe it like a puppet master pulling the strings on hundreds of puppets. And they'd basically be right. You see, usually when we refer to a botnet, we think of a collection of compromised hosts that is used to conduct some common activity. Sometimes it's a DDoS attack, sometimes it's to manipulate activity on social sites, or maybe it's as simple as renting out hosts to run your RuneScape bot scripts in bulk. Whatever this case may be, botnets are just one example of a concept that utilize the idea of command and control. Now, command and control is a lot simpler than this. You don't have to understand botnets to know how C2 works. Command and control at its core is simply being able to execute commands on a system that you can control. Let's put this into perspective for a minute. Think about SSH. SSH is a protocol that allows you to log into a host and issue commands, which controls activity on the host, right? Well, that's it. That's all command and control is. It's really that easy. However, obviously SSH isn't the only way to interact with the system and issue commands. And most attackers aren't using SSH when they deploy a piece of malicious code to take over their target and execute commands. And this is why we've abstracted this concept into the idea of command and control. Now in this particular video, I want to introduce some basic networking concepts and then show how those concepts work in a simple tool like Netcat, and then scale it up to a more complex tool made for this activity like metasploit. I am expecting most of the audience to be at a certain skill level that assumes basic networking fundamentals, some programming, and good CLI chops. If you don't quite have those yet, that's okay. Feel free to follow along anyway. But if you feel yourself getting lost, I highly recommend checking out Hack5's Hack Tip, Live Overflow's Introduction to Linux, and John Hammond's tutorial series, pretty much any of them. I'll leave some links to those videos below, along with links to a few war games that I like to recommend to anybody who's new. So as part of further setting expectations here, this series may not be for beginners, but I am making it very accessible to those who may be new to offensive security. A lot of these videos are things that I wish I knew about as I was learning and had to figure them out by trial and error. For those that are more experienced, you may still get value out of some of the later videos in this series, but just a fair warning, it may seem like beginner stuff as we get started. So hopefully that sets everyone off in the right direction. Let's dive on in. First, I want to talk about a basic network attribute or concept known as direction. Assuming that you have a good understanding of basic networks, you will know that a simple way to view a communication is that you have a host connecting to another host on a particular port. The direction of that communication is basically a matter of perspective. If I am a host that is connecting to the other host, we'll call me the client and the other host the server, just to keep things less confusing. Okay, So if I'm the client connecting to the server, my perspective is that the traffic from my system is going outbound to the server. From the server's perspective, they see my traffic as coming inbound to their server. If the server then talks to me, that gets flipped. You see, now the server will see itself as communicating outbound to me, and I see it as coming inbound. These are some very basic concepts, but it's a very important thing to correlate because it's going to tie back to some terminology that I'm going to introduce as it relates to C2. So for C2, you usually have two fundamental options in terms of network flow. There are bind connections and reverse connections. From the perspective of the C2, we are acting like the server in our example. We can talk to our clients or make them talk to us. So if we talk to our clients, we see that as traffic going outbound from us and inbound to our client. This direction in C2 terminology is what's known as a bind connection. We are binding to some port over some protocol to our client and then telling it to execute commands. If we make our client talk back to our C2, well, our client now views that communication as outbound and we view it as inbound. This type of connection is known as a reverse connection. Reverse is a term that confuses some people at first because it's not really reverse in terms of direction, but that's why the perspective is so important. See, the client is technically binding to us in this scenario, but we aren't viewing this from the client's perspective, we're viewing this from the C2 server's perspective. So instead of binding to our clients, we are just flipping the direction, or reversing it, to talk to us instead of our C2 talking to them. Hopefully that makes good sense. Basically, just understand that a bind connection is the server talking to the client, and a reverse connection is the client talking to the server. This reverse connection concept scales to a lot of other areas, like VPNs, for example. I encourage you to go research different ideas and execution of this concept because it's so simple and fundamental that often all the crazy stuff is hard to find. There's some good nuggets of information out there. Hack5 in particular has some good practical and abnormal examples just all throughout their videos, not even intentionally. So go out there, research, and learn some more. Anyway, to demonstrate the basics of C2 and these bind and reverse communication concepts, I'm going to start out by using a tool known as Netcat. Most of you have probably heard of Netcat, and if you're in my target audience, I really hope you have by now. If not, allow me to just quickly introduce you. Netcat is known as the Swiss Army knife of networking tools. Basically, it's just a fancy networking tool that lets you talk to systems in a more moral manner than the CLI interface. So we'll look at a quick man page reference for Netcat. And one of the things that you can do with Netcat is actually this very bare bones C2 communication. Netcat usually has the ability to execute whatever you tell it to and serve that command or application on whatever port that you specify, and that's using this TAC-E flag. Now, there is a second version of Netcat that's the BSD variant that removes this feature, and that's just kind of a note so you are aware of it, but that's not going to be really relevant for this series. Although be sure to check out my upcoming live streams because you never know what we might encounter. All right, so first I want to demonstrate a bind connection with Netcat. We aren't going to be doing any C2 just yet. I just want to show the very basics of us connecting to the server and the server connecting to us. So for a bind connection, I'm going to visit the client and tell Netcat to listen on port 444. So I'm going to do that by typing NC for Netcat, tech LVMP, and then quad 4s from our port. Now we actually don't need all of these parameters here, but I'm going to go over each one that we're using and why very briefly, but all we really need is L and P. So TAC L is for listen and P is for port. So if we have those two, we're telling Netcat to listen on a port. V is for verbose output, and I'm doing this so we can see the actual connections come in for visual purposes, so you can actually see when something connects. And N is to not do DNS lookups. Not really important in this case, but it's just kind of a habit that I have, and I always type it in. But that's so if we're doing like raw IPs, it's not going to try to resolve any DNS names, which we may not want to have that extra traffic going on. It may not be something to care about. Might be considered a speed boost and all that kind of stuff, but not really what we're concerned with going over. This is just kind of a recommended combination that I tend to use, but technically only TAC L and P are what you need to actually start a listener. So before I do that, I'm actually going to look up the IP of this host so that we have it, and I'll copy it. And then we will start our listener on port 4444. All right, cool. So we've got our listener, and what I'm going to do now is connect to this listener from my server. So I have this metasploitable box here as our client, and then every activity in the left pane over here is from my other box that is our server. So these are two separate hosts that we're doing communications over. So from my server, I'm going to bind to my client that is listening on this port. And I can do that by typing in Netcat, the IP address of my client, and port 4444, which is the port that is listening on. And if I hit enter, I will connect. And I can actually see that this connection came in successfully from my host over here at 3.120. Awesome. So that is how a basic bind connection works. For a reverse connection, we just swap the operations. So instead, over here, we're going to, on our server, listen on port 444, just like we did on our client, but now we're listening on the server. And you'll see it's actually starting Ncat. That's just because I have Netcat alias to Ncat. For the purposes of this video, these are fundamentally the same thing. However, I will have a video later on in the series that goes over the differences between Netcat, Ncat, and SoCat. So just stay tuned for that. For now, don't really worry about that. We're using them the same, and they function fundamentally the same for our purposes. So we're going to now connect back to our server from our client on port 444. So now we're logged into our server, or to our client here, and it's going to call back home to our server that is listening on port 444. And we hit enter, and then we can see we have a successful connection. Cool. So that's the first one was a bind, and that was an example of a reverse connection. That's all there is to it. All right, cool. So we're talking back and forth now, but how do we execute commands? Well, in the version of Netcat that I'm using, we can simply execute commands by passing it the -e flag. So let me set up another listener here, or at least start one. And then we'll say -e. And what we'll do is we'll specify, I know this is in user bin, we'll specify the whoami command. And what this is going to do is just execute whoami whenever a client connects to it and send the client, or whenever our server connects to it. I say a client as if it's a client connecting to something. Our server is going to connect to it, and it's going to receive the output of the whoami command. So let's listen. And then we'll connect to it on 444, and we should receive the output of the whoami command. And as msfadmin, you'll see it closes out the connection here, kind of leaves us hanging here for some reason, but we got the output of the whoami command, which is awesome, right? Let's do the same thing in a reverse context. So now we're going to listen on our server here, and we are going to connect and pass it the -e flag again, just like we did before when we did our reverse connection, and we're going to send it the whoami command. This should send it to our server with msfadmin. It's going to execute it, send it, and there we go, msfadmin. So now we're executing commands. That's awesome, right? But we don't really want to just do single commands. It's really kind of lame. We want to fully interact with the system just like we have an SSH terminal, right? So to do that, we can just send over bin bash or bin sh. We just send over a shell. And so we'll demonstrate that now. So just like we did before, I'm going to listen on port 444, but this time I'm going to execute /bin/bash. So now a bash terminal is just listening on port 4444 of our client. So we're going to now connect to that, and we don't get any output, but we do see that we have a successful connection. But what happens if I run whoami now? All right, and I can also execute other commands like id, ls, which. So I'm interacting with the system. I can actually move around, so I can go to /temp, see what's in there, cd back in the home directory, see my current working directory. Yeah, so we have a shell. It's just a full access shell, but this is a bind shell. So we're connected to our client here. We want to demonstrate a reverse shell now. So we'll listen now on our server, and just like we executed whoami connecting back, we'll send bin bash. So this is going to be a reverse connection, sending us a bash terminal. So we send our bash terminal shell. I'm using terminal and shell interchangeably for those who may not be familiar. So if you're real techie and technical about that type of stuff, I know bash is just the shell and a terminal is a terminal. Don't worry. But for all intents and purposes, we are trying to get a session, right? We're trying to interact with this like we're interacting with SSH, and we can do that now. So this is our reverse shell, and it's working great. So I said this is just like a normal SSH session, but that's not quite the whole truth. It is true that we can basically interact with this terminal just how we normally would if it were an SSH session, but we are actually restricted in some ways, and there are some frustrating aspects of using a shell in this format, but there are ways to upgrade and break out of that. Now, shell upgrades are out of the scope for this series, but I definitely recommend watching a few EPSEC videos, as he does a great job of kind of demonstrating that. It's just kind of built into his process. He upgrades simple Netcat shells, and he uses it very often. So you can probably watch just any video that's a Linux box, and you might have a chance of catching that process. I can also do a video on that in the future if you all would like, but for now, let's continue. All right, so to kind of close things out, I want to scale up what we just went over to metasploit. We'll have an entirely separate video on metasploit specifically, but at the beginning I mentioned how botnets kind of relate to C2s, and I did this to give you all an idea of how robust C2 communication can be. So it can be as simple as these little Netcat connections just handling one session at a time, or it can be as complex as metasploit C2 handling several connections at once. So first I'll demonstrate how to connect to a bind shell with metasploit, and then we will also handle catching a reverse shell to show that we can interact with multiple sessions and maintain them all in one central location with metasploit. Metasploit can actually interact with simple Netcat sessions. So on my client, I'm just going to run Netcat like we did before. So run Netcat, or listen on port 444. And I'm actually going to background that, so it's just going to be running as a background job, so that way we can execute further commands later. So now I'm going to load up MSF console, and I'm probably not running my database, so it's going to throw me a warning, but that's no big deal. And once that loads up, I'm going to use exploit multi-handler. And this is Metasploit's built-in shell handler. It's multi-handler, handles multiple sessions, right? And we're going to set the payload. There is a generic shell handling payload that just kind of magically works, but I don't know what that is. So if you know what that is, comment it below, because I don't have it written down in my notes and I don't know what it is off the dome, but I do have a payload that I know will work. So we do a uname-a. I want to get the architecture version so it looks like we're 32-bit. So I'm going to set the payload here to a Linux x86 shell bind TCP. So remember, this is going to be a bind connection. And then I'm going to set the remote host to our client, and set the remote port to 444, which it is servicing on. And before we do this here, I am going to tell Metasploit now to exploit this connection. And something important to note here is that I'm not actually exploiting anything. This is just Metasploit terminology, because this is an exploit module. Now technically I could also just type run to execute this module, but what I want to kind of get across here is that no vulnerability is really being exploited. I'm simply connecting to some pre-staged listeners that I have set up. Now, you may argue that these are backdoors and the exploit is me abusing the fact that there's a backdoor. And that's fine. You're technically right in some cases, but it just depends on the scenario. And in this case, these aren't really backdoors since I'm staging everything on purpose in this particular manner. It's all really just semantics, but I just wanted to note that because I think it's important, since this module isn't technically exploiting anything like you might think of in a traditional sense. So we're going to run our exploit now, and we'll run it with exploit -j. And I do this as a background job, so when the shell connection comes back, I can continue to interact with the console. If I were to just run or exploit, it would immediately drop me into the shell, which I don't feel like doing right now because I'm going to catch another shell in just a minute, and I want to be able to demonstrate that we're handling two shells at once. So I'm going to run exploit -j, and we can see that we had a successful connection to the client and command cell session 1 was open. But I can still interact, and I still have that connection going, and I can even still interact over here, although it says the session was stopped. Hopefully that doesn't break anything, but we'll get the point across. The next thing I'm going to do is set payload to be Linux x86 reverse, or sorry, shell reverse TCP, right? And then we're going to set our L port to us, and I believe we were, I don't remember actually, if config, set L port to, we were 120, and set, set L port to 444, set L host to 120. So we're setting the port we're going to listen on to quad 4s, and we're setting the host, that is us, that we want to connect back to. And we'll run exploit tag j. And since this is a reverse connection, this is actually just going to sit pretty and listen for us while it waits for a connection. And then we can kind of go up in our history and send this back a bash prompt, and it should catch it just fine. So let's do that. And we can see command cell session 2 opens. Now if we type in sessions, we can see that we have 2 sessions open, and we can interact with each of these. One is a bind shell, which is our first one here. And one is a reverse shell, which is this one here. And we can actually see the direction indicated in metasploit. It's very helpful. So here we see 120 is connecting to 227. So this is our bind shell. And here we can see 120 is listening on 444 and is interacting with 227 here. And I say the direction is helpful. I'm kind of being nice. The arrow is technically the wrong way here, but it's all about that perspective. And what you should be paying attention to is the ports. So we know that our shell handler is here, and we know that the shell handler on the bind connection is here, and you know what host is which. So this just helps you visualize it a little bit, although I wish the direction would be more symbolic. But I digress. Now we can actually interact with either of these. So let's do sessions tech I1. And it looks like our shell died over here, and that's okay. We kind of get the idea. The reason the shell died is because I was trying to be fancy and run it in the background. If I started a whole other session, it would work just fine. So that's exactly what I've done now, because I want this video to be a little bit more complete. So I know that while that might have been a bit confusing, what we'll do now is start another session here that is listening on port 444 and serving up bin bash. And we are going to kind of go back and set our payload again. So we'll set it back to our shell bind TCP payload. And we'll look at our options real quick to make sure everything's good. It looks like our L port is set correctly. So it looks like our R host is set correctly. We'll set our R port again just in case. Oops. And we'll exploit this, and it should connect. And there we go. So now we have sessions again. So sorry about that little demo screw up live in the video, but you know, that's how we do it over on this channel. So if we interact with session 2, this is our reverse shell, we see that we're successfully executing commands. And what's nice about metasploit is even though this is a basic command session over Netcat, it's not even like shell code, I can still type in background and background the session and come interact with it later. And I can do the same thing over here with our bind shell and connect to session 3, and now we'll see that I'm interacting with it again, and I can also background this. So we can see that metasploit is just one example of a framework that's very powerful for handling C2 communication. So in either scenario now with this tool, I can interact and manage multiple systems. We just used one for example, but while I'm technically running this on a single server, it does scale up in exactly the way you might think it does. All I have to do is tell Metasploit where my next client is, and it'll handle the sessions in the background for me. This scales up to hundreds, but I do believe there's some technical cap. You likely won't run into this when pen testing, but just do note that it's not infinite. And as we explore different tools, they'll all have different kind of constraints like that. So that's the basics of C2s using Netcat and Metasploit as examples. So I hope you all learned some cool fundamentals about C2s. Go practice and learn more, and I'll catch you on the next video. Thanks.